So let me tell you last time actually what we are doing. So let me little bit recall. So here it is. See, last time we saw the vector in space, right? So we have a directed line segment in space, right? It start from a point and it end up at a point. So let's say it start from the point O and it end up at the point A. So and it is a directed line segment. Let's say it is from O to A. Now we consider here two, the x-axis, y-axis and g-axis, right? So like that. So x, y and this is z. Now then the point C, the point A will have a coordinate. So let's say the coordinate is A comma B comma C, right? With respect to this coordinate axis x, y, z. So now see the same point, that this point A point, we can think two different way. One is using coordinate A, B, C. So this means this is A, then this will be B, and this will be the C, like this distance. This is A, this is B, and this is C. So then we get the point ABC. So we move A unit along x-axis, B unit parallel y-axis, and C unit parallel g-axis, and we get the point A. So the A point has coordinate ABC. Now the another way thinking the point is as a vector. So where the terminal point will be the point A. We think from the point A up to, sorry, from the point O up to A, we have a directed line segment. That way also we can think. So that concept is called the vector concept. This vector we denote it by u vector, and u vector will be basically will have component A, B and C, or the linear form will be A of I cap plus B of j cap plus C of k cap. So the same point A we can think two different way. The first thinking is the scalar thinking, and this second thinking, the directed line segment, is the vector thinking. Okay, Maya?
Okay. Fine.
Yes, right. Now, just keep this thinking in mind. We will solve the exercise. So all the scalar, like distance between 2 point, all the thing you can here write. So basically, okay. So let's see the exercise 31. What is it? So 31 tell us that. So can you open the exercise 31, 11.231? So then it will be good for me if you read one times. Can you read it please? 31 exercise.
3111.2.
Yeah.
1 second.
Mm-hmm. Yes. So I'm writing here the exercise. Just you tell me.
Okay.
Yes, please.
It says
Mm-hmm.
um find the lengths of the sides of the triangle with the indicated vertices and determine whether the triangle is a right triangle and an isosceles triangle or neither.
Yeah. Yes, you are correct. So let's say we have the triangle called A, B, C, the vertices, right? A has coordinate 1,
Yeah.
-3, -2. Yes. Yes, please. Do you want to say something?
No.
Okay, so B has coordinate 5, -1, 2, and C is this. Now we first what we do, just knowing the length of a triangle, we can classify, right? The the triangle, it is right angle triangle or it is isosceles triangle, like that. We can, I mean, we can divide, right? Triangle in different time, right? So what we have to do? We have to calculate the length. So the distance between AB point will be what? Square root of 5 minus 1 whole square plus, minus 1 plus 3, that whole square, right? Plus 2 plus 2, that whole square. Is it okay, Mayan? A and B has coordinate, then we use the distance formula. Okay?
Okay,
Right.
fine.
Yeah. After simplify, let me write here. After simplification, what you get? This is 4 square, this is 2 square. So 4 square means 16, right? And then 2 square means 4. And then again 4 square means 16. So this will be basically 20, 36. So square root of 36 means, 6. Okay. 20, 16. Yes, right. Yeah. Similarly, calculate BC. The BC length will be what? Square root of 5 plus 1 whole square. This exercise is very much easy. Just mathematically what we are doing, we just calculating the length of the side, right, of the triangle, where the coordinate of the vertices are given. So this yeah, so this one, this, and what is this? This is basically 36 plus 4. So this is square root of, what you get here, you basically get here that 40, right? Now what is AC? AC will be basically square root of 1 plus 1 whole square plus 1 plus 3 whole square, and then 2 plus 2, that much whole square. So what we are getting? We are getting 4 plus 2 square is 4, 4 square is 16, and 4 square is 16. So we are getting here 6. Yeah, is it okay, Mayan? Fine.
Yeah, fine.
Okay, now see, since AB, the side AB equal to the side AC, the length, so it is isoscale triangle, right? Okay. Because we have to classify, right, which triangle it is, isoscale or right angle. So it is isoscale, right? So now the question here, let me, although it is not a right angle triangle, but let me uh, tell you, if you know the length of a triangle, three sides of a triangle, then how you check that is right angle? How you check? Do you know, man, how to check a triangle is right angle? If you know the side length of the triangle using those, let's say you have a triangle, A, B, C are the length. This is 90 degree. So let's say this is perpendicular. Yes. Do you know, man, using A, B, C, can you write the criteria that allow you to check the triangle is a right angle triangle?
Yeah.
Just knowing the side.
Well,
Yes. Pythagoras.
doesn't Python have to work?
Yes, exactly. So ABC right angle triangle, ABC, this triangle is right angle if and only if one side square, we don't know which side, but let's say one of them, one side square equal to sum of the other two side square, right?
Doesn't
That,
have to be hypotenuse squared?
yes, but we don't know which one.
Oh,
There
we
will
don't know
be,
which is hypotenuse. Okay,
yes,
sure.
yes, yes, yes.
So
So
then do you have to calculate which length is the longest?
yeah, yeah, yeah. Which length is the longest?
Because we
Exactly.
have the values of A, B, B, C, AC.
Exactly. Exactly. You are right. Which length is the longest? That will be the
So
hypotenuse.
since AB and AC are the same, then I think it's BC. It's the longest. And it's root
Longest?
40.
Yes, but do that satisfy this Pythagoras theorem? So, I mean, the square root of 40, that whole square, is it equals to,
Wouldn't this just be isosceles because two of them are 6?
yeah, that they are isosceles. You are correct. Isosceles. Very good. So, yeah,
Okay.
we wrote it here, right? This is isosceles triangle.
Oh, wait, I'm blind. Sorry, yeah.
No, it's okay. But see, just I'm telling you that, the largest side square is equal to 6 other two side square. Is it true or false? No, right? This is not true.
No.
Not true. Yes. So it is not a right angle triangle. It can be happen that isoscale and right triangle both. It can be. Okay. There is a triangle which is both isoscale and right angle. For example, if you take this one, 1 by square root of 2, 1 by square root of 2, it is isoscale, right? And it is 1. Okay. This is both. Is isoscale, right? And also,
Yeah.
yes, and right angle. Why it is right angle? Because 1 by square root of 2 whole square plus 1 by square root of 2 whole square equal to 1 square, right? This identity, I mean the Pythagoras identity satisfied, right? So it can be happen. So that's why we have to also check that this condition satisfy or not. Here it not satisfy, so it is not right angle. Okay, so next move to the next question. Any question from this exercise, man? Is it okay? 31.
Yeah, that's fine.
Okay, just we deal in this exercise with the how to find out the distance between 2 points. That was the here the main the work we did here. Okay, next. So the next exercise is 31 then 35. So find the coordinate of the middle point of the line segment joining these 2 points. Okay, one thing I tell you, man, that if you have a point, let's say A and let's say another point here B. Okay, so let assume the coordinate of A is x1, y1 and g1, and B has coordinate x2, y2 and g2. I think that I'm going to tell you this is new for you. I'm not sure, but I think you know how to calculate middle point. Do you know, Mayan, how to calculate middle point of this line segment? The formula. Let's say this is the middle point called M. Do you know, Mayan, how to find out the coordinate of the middle point of the line segment AB, where A has coordinate given, B coordinate is given? Hmm?
Yeah, through a distance formula.
Middle point. The middle point. Coordinate of the middle point. This is the middle point. Not distance formula. I want to. We want to write down the middle point. The coordinate of the middle point. Okay. Can you remember
Okay. Yeah.
how? See the given here A and B coordinate. Using that two coordinate, can you write down the coordinate of the M point?
Okay.
Yeah. Can you remember it? You did it. But let me write it here. It will be the sum of x coordinate divided by 2 comma sum of y coordinate. It is average, right? Right, man? Okay. So for example, so let me tell you, normally if you have, let's say on real line, let's say we took here, okay, so let's say 2 and let's say 4. Okay, fine. 2 and 4. What will be the middle point between 2 and 4?
3.
3. How did we get 3? So
4
3 we
plus 2 divided by 2.
very good. Yes, the same thing we did here. But here, the point is not determined by a unique number. It is determined by 3 numbers. So in every 3 place, you have to take the average of that, the values, right? Corresponding coordinate values. Yeah, that is the idea. How to remember this. Okay, fine. So here it is. So if you want, I can tell you little bit general that, if you have A, so just for your convenience, I can tell you little bit, extra here for this contest. So A has this point and B is this point. So let's say, instead of dividing, this point has coordinate x1, y1, g1, and this point has coordinate x2, y2, and g2. So let's say instead of taking middle point, we take a point P here that divides M is to N ratio. Okay. Okay. So this
Yeah,
means,
fine.
yeah, then what will be the coordinate of P? right? So here AP, we are saying that AP by BP, this ratio is basically, let's say, M by N. Suppose we know this. So suppose we have given 2 point A and B, and we have a point P in between the point AB that divides the segment AB in the ratio M over N. Then we want to calculate the coordinate of the point P. So what it will be? So it will be basically, let me write down here. This point coordinate will be, it is here that, so you take here M. So first we are writing the X coordinate. So M into X2 plus N into X1 divided by M plus N, comma. So what we did, M we multiple with X2 and N we multiple with X1. So how you remember? Just see, M is with this X1 coordinate. So M you multiple with X2. That we did it. So and N is with X2. So we N multiple with X1 and put it here. And below sum always. Same thing for Y. M of Y2 plus N of Y1 divided by M plus N. Then M of G2 plus N of G1 by M plus N. Okay, Mayan? Is it okay?
Yeah,
Right?
that's fine.
Okay, very good. So that is the idea. How to, instead. So in this case, we have middle point situation. It divide the point M, divide the segment in ratio 1 over 1. Same. So M1, N1. Then you getting this. Right. Okay. Okay. So we are ready to solve that exercise now. So find the coordinate of the middle point of the segment. So once you know this, it is very much easy. You can solve. So should I leave for this exercise for you? 35. Can you check, please?
Yeah.
Okay.
I think yeah, you can leave it.
Yes. Okay. Right. So 35 done. Then 38. So 38 is what? 38 is, here it is, standard equation of the sphere. So let me tell you, man, the sphere. Sphere mean what? So here I am writing. So it is a 3 dimension. The name of circle, right? You can say the 3 dimension. You can say the next version of circle. Okay, you can say like this. Okay, the same definition. So let me write down here the circle and sphere both together. So we try to understand what is the difference of circle and sphere. So both has the center, right? So let me, so center, yes, it has center. If I'm taking here the center and asking the question, this has center, and the answer is yes, right? Circle has center, sphere has also center, right? Radius, yes, both has radius, right? Circle has radius, sphere also has radius, right? Okay, Mayan. So both,
Yeah.
yeah. So yeah. So let me draw here, as here circle we draw. We also draw the sphere. Here we took the point center, let's say O, because both has center. Here we also take the center. Now we have one more thing that is called the radius, right? So also we have the radius. So let's say this is the radius for both. Yeah. Now here the important thing. So restrict on plane, restrict on plane. So let me write it here. So I'll need a space. So restrict on plane. For circle, yes, you have to restrict on a plane, but for sphere, it is not necessary. I mean, not needed. You can move, in space. Okay. In other way, you can say this is 2D, two-dimensional, and this is three-dimensional. Okay, fine.
Yeah.
Yes. So this means you are in the same plane in the whiteboard. Let's say we keep same distance from the origin, I mean the center, and move around that. So let's say the radius is r. But here the radius is r. We not just moving around on this. I mean this situation. We also move like that. That this way we also move, right? Keeping the same distance. The same thing here. Same situation. So we are getting a three-dimensional. The surface, right? That is the sphere. So the sphere is basically a surface, such that if you take any point on the surface, then you know the distance or any position. If you take the any point on any position on the surface, then you can see that the distance of 2 points same from the center, right? That is the idea of the sphere. Now look at this. The exercise 38, I think we have the exercise 38. Yes, if you look at the exercise 38, so can you open exercise 38 please, then I will start solving. If you read it. Yeah, 38.
38 says,
Mm-hmm.
find the standard equation of the sphere. So
Uh-huh.
the center is at 4 comma negative 1 comma 1, and the radius is 5.
Very good. And radius is 5. So to draw a circle, if we know the center and radius, then you can write the equation. Okay, how?
Yeah,
So the
correct.
yes, very good. So center is given here. So let me write here center 4 comma negative 1 and 1, and radius is 5 unit. Now see, if we take any point on the sphere, we don't know the sphere how looks like. So maybe this way it looks like, right? So if you take any point on the sphere, right? So maybe this. So this is any point here. I took, let's say, x, y, g. Okay, man. Just take any point x, y, g, right? So then x, y, g, c lies on circle. Lies on sphere. If and only if, what is the condition? The distance between x, y, g and the point 4 negative 1 comma 1, this will be 5. Okay, Mayan? The distance.
Okay.
Yes, that is. Now we know the distance formula. What is the distance formula? If you write here, it will be square root of x minus 4 whole square plus y plus 1 whole square plus z minus 1 whole square equal to 5, right? Okay, so if you write down it, it will be x minus 4 whole square plus y plus 1 whole square plus z minus 1 whole square equal to 25. Just we the remove the square root, so that's why the right hand side take we square, right? 5 square, so 25. Okay, man, this is the equation.
Yeah, fine.
Okay, this is the required equation of the sphere. Okay, so 38 done. So next is, let me tell you, 39. Please read the 39, man. 39, exercise 39. What is it? 39, can you read it?
It says endpoints of a diameter
Yes,
0, 0 and 0, 6, 0.
yes, yes. Okay, so the diameter endpoint is given. So we can do two different way, but here I am telling you only one way instead of doing geometrical. So just okay, so let me here. So we have diameter. My diameter mean what? So let me draw the sphere, then it will good for us. So here it is the you know so this is the, let's say, this is your sphere. So let me put it here this way for understanding that it is a sphere. Okay, man, this is sphere. Fine. This is the center. Okay. Now see diameter, let's say the diameter, we don't know, maybe this is the diameter. So diameter mean the second line of the sphere that passing through the center, right? So that has coordinate 2, 0, 0, and then this has coordinate 0, 6, 0, right? So we don't know this is O. We don't know the, let's say the center is this. So let me put here the green color for the center. So this is the center. Okay, Mayan, fine.
Yeah, fine.
Okay, so let me write here. Center is the middle point of this 2 point 2 comma 0 and 0 comma 6 comma 60. Okay, so the center will be what then? Once we know this situation, the center is basically 2 plus 0 divided by 2, 0 plus 6 divided by 2, 0 plus 0 divided by 2. Because we know how to find out the middle point. See, we want to write down the equation. The required is here. We want only given the diameter and point coordinate, we want write equation of above sphere. So see, to write down the equation of sphere, what you need? You need the center and you need the radius, right, Mayan? Okay,
Yeah, correct.
very good. Yes. So that's we are going to do here. First, calculating center, because the diameter and point given, so that center will be the middle point. So that we are calculating. So it is what? Basically, this is 1 comma 3 comma 0, right? Okay, Mayan. Fine. I think it's okay. Right. Okay. So now what will be the radius? So the radius will be the distance between 2 comma 0 0 to 1 comma 30, or distance between 1 comma 30 to 0 comma 6 comma 0. Any one you can take. So anyway, so let me take here distance between. So here it is. So distance between 2 comma 0 0 and 1 3 comma 0. And we know how to find out the distance between 2 points. So this is 2 minus 1 whole square plus 0 minus 3 whole square plus 0 minus 0 whole square. So this is basically 1 square plus negative 3 whole square plus 0 square. So this is nothing but square root of 1 plus 9, so square root of 10. Okay, so we have the center, we have the radius. Now we can calculate the the if x y g is any point here. Let's say we take a point x y and g is any point on the sphere, then the distance between x y g and the point, let's say the center 1 3 0, this is equal to c here. So this is what? This is basically x minus 1 whole square plus y minus 3 whole square plus g square. The square root equal to square root of 10. So this is nothing but x minus 1 whole square plus y minus 3 whole square plus g square equal to 10. See, actually, Mayan, here what we are doing, we are basically deal with the scalar, I mean the coordinate, all the thing. So far we did not solve any problem, involving vector, right? But it's okay. You know, to understand vector, you need to know the scalar equation. You need, if you know the scalar equation, if you know the vector, you can solve the scalar also. So that two are, I mean, the relate to each other. Okay. Hello.
Yeah.
Yeah. So next is 41. Exercise 41. Can you read 41, please? Exercise 41.
For 11.3, right?
11 point, no, 11.2. 41.
Oh, sorry. 11.2.
Yeah, 41.
It says complete the square to write the equation
In the
of the
standard.
sphere in standard form. Find the center and radius.
Yes. So let me tell you mine. Standard form mean if you know the center, let's say alpha, beta, gamma of a sphere. So let's say you have a sphere here, and if you know the center like this, so it is something this way. Okay. So then let's say the radius is, we call this is r. So the equation how looks like? Then equation will be, so the center, if you know the center at alpha comma beta, alpha beta gamma, and radius let's say r, then equation will be what? Equation is given by x minus alpha whole square plus y minus beta whole square plus g minus gamma whole square, this square root equal to r. So this is nothing but x minus alpha whole square plus y minus beta whole square plus g minus gamma whole square equal to r square. Is it okay, Mayan? Fine. Okay, this is gamma.
Yeah, that's fine.
Okay, so we will try to put our equation in this form: x minus alpha whole square, y minus beta whole square, z minus. Then from that we can calculate center and radius. We do that. So let me write here 41. So what is it? So x square plus y square plus g square we have now minus 2x, so plus 6y, and then plus 8g plus 1 equal to 0. So let me tell you my effect from algebra. A square plus 2ab plus b square. Do you know what is this? This is a plus b whole square, right, Mayan?
Yeah.
Okay, that we will use here to write down this in this form: x minus alpha whole square, y minus, because it is in the whole square format. We have to bring that in the whole square form. And this expression, a square plus 2ab plus b square equal to a plus b whole square, allow us to write down some, the three term together into a replaced by a whole square term, right? So let's do it. So firstly, what we do, we'll take all the x term together, and then we take all the y term together. So then we take all the g term together, and then constant. Okay, mine. Just first we take all x term, then y term, then g term. Now here, let me write here x square we have. Okay, let's write it minus. So okay, one more thing I forget to write down here, that it is needed here, that a square minus 2ab plus b square, that is also a minus b whole square. These two formulas are very much important, here basically to solve this kind of exercise. Okay, so then this is what? 2 into a, because minus a is x and you need 2x, so I need 1. Okay, fine.
Yeah, fine.
Yes, plus 1 square. This plus 1 square we bring extra, so we have to subtract by 1 square. So just this, x square minus 2x, we rewrite this way. Agree, Mayan? This part?
Yeah, that's fine.
Similarly, yes, we write down this the same thing. So here I am writing here. So plus sign we have put it here. So y square plus 2 into y, and then we need here 6y. So we need to put here by force 3. So 2ab. So there b square. Since we add this, so we have to subtract by this. Okay. Similarly here it is g square plus 2 into g into 4 plus 4 square minus 4 square, and then plus 1 equal to 0. Got it, Mayan? Is it fine?
Yeah.
Right. So what is this? Then, if you take this three term together, then you can replace that by x minus 1 whole square and leave it as it is, minus 1. So this is minus 1. And then plus, similarly here this term you can replace by y plus 3 whole square and then minus 9, right? And then plus, this is z plus 4 whole square and minus 16 plus 1 equal to 0. Got in mind? Then this is x minus 1 whole square plus y plus 3 whole square plus z plus 4 whole square. If you simplify, you will get here 1 1 cancel out, so 25 this side. Okay, 25 mean 5 square, right? Okay, man.
Yeah, fine.
Center will be where? Alpha, beta, gamma. Alpha is 1, beta is -3, gamma is -4. And radius will be what? Radius is 5. Okay, clear, man? Should I send you new link?
Yeah, sure. This one's about to end in a minute.
Okay, okay. But you got the point, right? Here,
Yeah, yeah.
basically this algebraic fact we have used here. Just writing down this equation, because you know the center and radius, then equation will in this form. So if we, you know, the here in 41 the question, the given expression expand form of this, right? So somehow we write down in the whole square form, and this is the algebraic trick here we use, right? And then done. Okay, I'm sending you the new link, man. Okay, then
Okay,
we
fine.
solve rest. Yes, thank you. Yes.